This instructional video is being prepared to provide the instructions necessary to remove the linear actuator from the elevation base. To start the job, there are a number of tools that are required. Going from left to right, we have a Phillips head screwdriver, we have a pair of wire cutters, we have a 5/8 9/16 inch wrench, we have an Allen wrench, we have a T-bar Allen wrench, we have two needle nose pliers, we have a small floor jack, and finally a wood block piece of 2x4. The next step will be to verify that the table is plugged into a power source, and at that point then we'll use the foot pedal and we're going to raise the table to its highest position. And we see the table is going up. And when it reaches the highest position, it stops. Okay? At this point, we'll take the block of wood. We'll place that in on the base, noting that the block of wood will be flush with this point here on both the left side and right side of the table. We will position the small jack on the block of wood, and what we want to do at this point is we want to demonstrate that there is a shoulder bolt that's holding the actuator in place, and what I'm doing here is demonstrating that I cannot move that shoulder bolt in its location. The reason for that is that there's already a load that's on that shoulder bolt by virtue of the mass of the base. Our objective here will be to remove that load, and once we do so carefully, we will be able to move that shoulder bolt to the right and to the left, and that has identified that the load has been removed. We're now in a position where we can proceed with the task. At this point, we're going to jack very, very slowly. The small groove that's in the floor jack will come in contact with the tube right here. And what we're doing at this point is we're jacking very slowly. Our hand is on that shoulder bolt, and now we can hear that that bolt is moving. Okay? That means that we have removed the load from the linear actuator. We will not jack any further. The jacking task is completed at this point. Okay, now that we've taken the load off the linear actuator, we will remove the power cord from the power source. Okay? That means that the table now is ZEPT, zero energy potential. And we will use our Phillips head screwdriver, and we'll go ahead and remove the 4 screws that's in this plate right here. There's 1, there's 2, there's number 3, and finally number 4. With those 4 screws removed, we now can lift the plate and we can reveal the wiring just underneath. Our next task is there are 3 tie wraps that are shown here, here, and here, and we will use the wire cutter to go ahead and to clip each of those tie wraps so that we can remove it. The purpose of the tie wraps is to route the electrical power from the power supply to the linear actuator. Okay, all 3 tie wraps are removed, and we can see now that the power cord is free and available. Alright, next step will be to remove the spiral wrap that's around that bundle of wiring. Very simple to do. Just unwrap it. And the purpose of the spiral wrap is to join together a group of wires so that we can control where those wires are going to be placed all the time. All right? With the spiral wrap removed, we'll now go ahead and we'll take our T-handle wrench and we'll be removing this button head screw that holds down those two wire clamps. Okay, and that's been removed. Take out the screw. We'll open up the clamp that's got the wiring inside. At that point, we're going to remove only one wire from that clamp, and it is a black wire that's got a blue and brown wire on it. The other wiring can stay inside that clamp. Okay? If all wires are taken out, it's not critical, but this is certainly the wire we want to remove because this is the wire for the power source to the linear actuator. Next step will be to take our two needle nose pliers, and we want to take care that when we separate these connectors that we do not pull on the wires. What we want to do is place the needle nose on one side of the crimp and the other needle nose on the other side of the crimp, not touching the wires, and then with that we can separate the two tools and we can disconnect those two wires. We'll perform the same function on the blue wire, and we've separated that. Now we're in a position where all of the electrical connections to the linear actuator have been removed. Alright, the next step, using our hex head wrench and our 9/16 inch ratcheted wrench, we're going to go ahead and we're going to remove the nut from this shoulder bolt, and that will remove one of the mechanical connections of the linear actuator to the table. And with the ratcheting wrench, it makes this job very straightforward, makes it very quick. Removing the nut from the shoulder bolt. And because we've already deloaded the base with our small jack, it's a very easy process to remove the shoulder bolt from the linear actuator. Alright, the last step will be to make the final mechanical disconnect, removing this shoulder bolt here. We're going to use our Allen head wrench, and we're going to use our 9/16 inch ratcheted wrench and make that disconnect. Allen wrench goes into the bolt, ratchet wrench goes on the nut, ratcheting it open as we've done on the other bolt. And we're out. At that point, we have deloaded the table. We have disconnected all of the electrical connections. The table has been zepped. In other words, it's not plugged into the wall. And the linear actuator is free to remove. That completes the task necessary for removal of a linear actuator from the elevation base.